Hi, in this video we will discuss any number given in base 10, how we can convert to any other base. Let's start from, for example, 25 in base 10. How we can convert this one to the base 6. Okay, this is really simple. What we are doing, we are getting 25 and we try to divide by which number system you are going. You need to divide by this. Okay, since you want to go to base 6, you need to divide by base 6 first. Okay, in 25 there are 4 times 6. 4 times 6 is 24. Okay, then remainder is 1. So what will happen, you will get new number as 4. Okay, 4 cannot be divided by 6. That is why your first number is 1 and second number remainder is 4. We can directly put here 4 and you start from bottom to top. That means that your number 25 in base 10 given, how we can convert to base 6 is 4 1. Okay, you can make some verification. What we can do, we can get number 4 1 in base 6 and we can convert back to the base 10. By this way you will see that we did correct or not. Okay, let's try to convert. As you remember from the previous video, it's equal to 1 times 60 to the 0 power 1 times 1, because 6 to the 0 is 1. This is 1. The second digit is 4. 4 times 60 to 1. That's gonna be what? 4 times 6. That is 24. As you see here, when we add these two numbers, 1 plus 24 is 25. By this way, we did our justification. 25 in base 10, how we can convert this one to base 6. As you see here, we got 4 1. Just we did reverse process. 4 1 really is equal to the 25 in base 10. Yes, we got it here. This is justification for our process. Okay, let's do one more example. We did base 6. Let's do another example. We can clear canvas or screen. Let's try to get another number. For example, 13. 1 3 we can write, but when we are reading this is in the base 10 or decimal, we can directly say 13 is equal to how much? Equal to in base 3. Very simple again. We are getting the number 13. Which base you want to go? Divide by with that number 3. In 13, how many times 3? 4 times. 4 times 3 is 12. 13 minus 12 is 1. This is your first reminder. Your second number, actual new number, is 4. 4 is bigger than 3, then we can divide by again 3 easily. How many times? In 4 we have 1 times 3. 1 times 3 is 3. And remainder is 1. Okay, this is another reminder. Okay, your new number gonna be 1. We can take this one and bring here. But as you see here, 1 is smaller than 3. It cannot be divided by 3. So we write from the last beginning. That means that the number is 1. Another number is 1. Okay. Because this is last number. Let's put a star here. And this is another reminder. Just I don't want you to confuse. And this is the first reminder. Okay, that means that we take care of reminders plus the last number. We cannot divide again. That is we are taking. So 1, 1 and 1. Okay, this is equal to in base 3 numbers. You might think about we did correct or not. Yes, if you like we can do one more time justification like we did in the previous example. Get 1, 1, 1, 3. Really it is equal to 13 in base 10. Okay, let's do the calculations. It's equal to the first digit 1 times 3 to 0 plus second number 1 times 3 to 1. Third number is 1 times 3 to 2. Let's try to find the value. 1 times 3 to 0, 1. If you like, we can write 1 times 0 power of any number is 1 plus 1 times 3 to power is 3 to the power 1 is 3 plus 1 times 3 to the power 2 is, as you know, this is 9. It is equal to 1 plus 1 times 3 is 3 plus 9. As you see here, we got 13. So that means that what we did is correct answer. You can increase the number of examples, but we can do one more, at least quick run to understand how we can come from the base 10 to another base. In the previous example we did base 6, here we did base 3. Let's try to make base 2. Okay, let's clean. Okay, let's get 17. Yeah, you can go bigger numbers, but bigger numbers division takes time. If we understand simple cases, we can do the other things easily. How we can convert 17 from base 10 to the base 2 or binary number systems? Okay, we are getting the 17. We want to divide by 2. 8 times 2 is 16. Remainder is 1. Okay, we can take a circle and we can make arrow. At least we don't confuse up which number we are writing when we are writing in the base 2. This is your first reminder. Okay, let's take new number. Your new number is 8. We need to take this new number and divide by 2 again. 4 times, as you see. 4 times 2 is 8. Remainder is 0. Okay. Let's take this one in the circle. Take this one here. This is another number. Another remainder. 0. Okay, your new number for the new division is 4. If you like, you can show with the arrow like that. 4 divided by 2 again. How many times? 2 times 2 is 4. Remainder is 0. Okay, we can take a circle. This is your third remainder. Okay, space might not be enough here, but what we can do, we can get the new number 2, because we will take and continue. We can take 2 here and divide by 2 again. Okay, how many times? 1 times 2 is 2. Remainder is 0. Okay, we can get this one another remainder. We need to write when we are writing the number in base 2. We have one more number left, 1. This will be your new number. But as you see here, this number cannot be divided by 2. That is why we will take itself. We are writing from last the initial or last the end to the beginning. So your first number, if you like, we can label it. This is your first number. We need to write here 1. The second one is 0. And third one is another 0. And fourth one is 0. And the last one is 1. This is in base 2. Let me write the same number here. 1, 0, 0, 1. That means that 17 in base 10 is equal to 1, 0, 0, 0, 1 in base 2. If you like, you can do reverse process. You can take this number, okay, convert to base 10 like we did today for the previous examples. You will see that it is 17. Okay, so number of the examples can be increased, but before we go more in details, I want to do one more thing, is how we can convert from base 10 to base 16. Okay, suppose that we can get 67 in base 10 is equal to how much in base 16? Base 16 is hexadecimal. We are getting 67. This is your number. We need to divide by 16 because we want to go to base 16, as you see. Okay, how many times 16 in 67? 2 times 32, 4 times 64. That means that if we make this one 4 times, that's gonna be 64. Okay, your remainder will be 3. We can take a circle. We can put here to reach easily what number needs to be right, needs to write for base 16. Your new number to be divided by 16 is 4. 4 cannot be divided by 16. 0 times. Actually, this is much smaller. Am I right? Smaller than 16. just we are getting itself. That's gonna be 4. Okay, if you write from bottom to top, your number will be 4 and 3. Please be careful. If you write 3, 4, suppose that this is a multiple choice answer, you will see that it will be wrong. Okay, let's do one more. Suppose that 19 in base 10. How we can convert to base 5? It is simple again. What you need to do, we need to get, maybe we can separate the previous example like that. At least we can save our place. Take 19 divided by 5. How many times 5 in 19? 4 times is 20. No, that means that it should be 3. 3 times 5 is 15. Remainder is 4. So you need to get this 4 here. Your new number is, to divide is 3. You can bring here. But as you see here, 3 is smaller than 5. We cannot divide. We can get this 3 and directly here as a remainder. And start from the end to the top. Your number will be 3 and 4. Okay? Actually, it is not difficult. Just you try to be careful when you are doing division. Sometimes some people divide directly, make division by the calculator. In the calculator, yeah, you don't, if it is the good number, whole number, you can get it some remainder 0, but if it is like a decimal, all the time you need to get remainder. I think we will continue in the next video how we can convert from one base to another base. And for the coming videos also we will do many short questions and answers from one base to any base, or base 10 to another base, how we can add also numbers in binary systems by using the rules and decimal place calculations. Then we will continue.